Hello everyone, my name is Naveen and I'm Microsoft certified trainer with SSDN technologies, and I'm delivering the training for uh, Active Directory, for Windows, for authentication, for SSL, TLS from last approximately 5 years. Okay, so shall we start now? Now, this presentation is all about how SSL and TLS Handshake works. So why I'm talking about SSL and TLS Handshake? Because whenever we talk about the secure communication between the client and server, or between the two servers, or between the two clients, SSL and TLS Handshake plays a very important role. In domain environment, we have the different authentication protocols like Kerberos and TLM, through which we can verify the identity of the user. We can verify the authenticity of the user who is trying to access the resources. However, as of now, we have the different resources that we need to access it over the wire on internet. On internet, whatever it be the machines, these are not the domain joined machines. So how do we need to provide the authenticity of the user or the authenticity of the server? So basically, the SSL and TLS handshake is all about, for an example, if I'm accessing the website for any bank, like citibank.com, as I'm a user, I would like to know that the website that I'm authenticating, this is from Citibank only. There is no impersonation in between, and there is no man-in-middle attack. So SSL TLS plays a very important role in that. And as of now, if we talk about any technology, every technology is moving on cloud. So if we talk about cloud, SSL and TLS handshake would be one of the most important thing that comes in picture. So SSL handshake provides, it encrypts the sensitive information. It provides authentication, authenticity of the server, authenticity of the client. It provides trust. So we will talk about how SSL and TLS stack look like. SSL and TLS stack, I'm talking about whenever we talk about how do we need to check the data in any of the network tool, like network monitor or Wireshark analyzer or netmon. So how the SSL and TLS stack look like? So there would be network layer, IP internet layer, and TCP, that would be the transport layer. And above that transport layer, we have application layer, and in that application layer we have SSL record layer protocol. And whatever the data that we have in the application layer, it is encrypted. And at the application level, we can see SSL handshake protocol, SSL Cipher protocol, change Cipher protocol, and SSL alert protocol. SSL handshake protocol would be the SSL handshake when the client sends the client hello, server sends the server hello, and after that they try to interact with each other, set up the secure channel. And the change Cipher would be the flag from the server that indicates that yes, I'm ready for the secure communication. And during that secure communication, if there would be any alert, it gives us the error message in the form of SSL alert protocol. So if you check these traces in any of the network analyzer tool, first of all, you will find that there would be a TCP/IP handshake. After that TCP/IP handshake, there would be SSL handshake. And after that SSL handshake, we will find application data if the SSL handshake is successful. If the SSL handshake is not successful, we will get SSL alert code. And this is how SSL and TLS handshake works. So because SSL and TLS works over TCP/IP, so there would be a client. The client I'm calling to that entity which is initiating the client hello, and the server would be the entity which is initiating the server hello. So first of all, client send the TCP/IP sync, server reverts sync acknowledgement for that sync, and the client send, yes, I have acknowledged your SYNAC, and the TCP/IP handshake has been completed. Once the TCP/IP handshake has been completed, after that client sends the client hello. In that client hello, client sends SSL protocol version, session ID, list of Cipher Suites, and the client hello extension. What are the client hello extensions? We will look into that further. As soon as the server get the client hello packet, it checks what would be the SSL protocol version on we need to talk. It creates the session ID, and it selects the Cipher Suites on which we need to work. It sends the server authentication certificate to the client, and it can also request client certificate if the mutual auth is enabled and the client certificate is required. And when the client get the server hello, after that there are a few methods through which client generates the pre-master secret, and if the certificate has been required, that is optional. It has been sent to the server. That is in the packet of client key exchange, and after that server send change ciphers back that yes, I'm ready for the SSL communication. And after that, application data exchange starts. When the client hello has been sent, in the client hello, we send TLS protocol version. The TLS protocol versions would be SSL 2.0, SSL 3.0, TLS 1.0, TLS 1.1, and TLS 1.2. So it sends the protocol versions that are enabled on client. Client generates the random number. That would be the random pseudo number that has been generated on the client. It can be any number. There would be no sequence or there would be no method for that. And when client initiates the first session, it creates the session ID. If the session has been resumed, it can use the previous session ID. However, which session ID do we need to use? That would be the decision of the server. Apart from that, in the client hello, we get the list of all the Cipher Suites, server name indication, where we have the name of the server for which we would like to contact, and the supported hash algorithms on the client machine. When this client hello has been received by the server decides on which TLS protocol they need to talk. They select the highest protocol version, whatever it would be available on the client and on the server, which is common. Now here, server generates its server random number, server generates the session ID, and server has its server authentication certificate. So it sends the public key, like it sends the certificate without private key in the server hello packet, and it also sends the Cipher Suite on which we need to talk. Now, as soon as the client get the server authentication certificate, it validates the certificate. In order to validate that certificate, it verifies the chain of the certificate. It verifies the revocation of the certificate. just to make sure that the certificate that has been provided by the server for the server authentication is a valid certificate and I can trust that certificate. So in order to do that, there would be two functions that has been called. One is cert get certificate chain start. That is for the chain validation. The chain validation means the certificate of the end entity, that would be the server authentication certificate, and the certificate which has been issued by uh, the issuing certificate authority certificate and the root CA certificate authority certificate. And after that, the revocation for all these certificates has been started. The revocation means whenever we issue the certificate, the validity of the certificate, there would be a certain a time period for that certificate, like maybe for 1 year, maybe for 2 years, maybe for 3 months. However, there would be some circumstances where we need to revoke the certificate before its entity. In that situation, it can happen because of a number of reasons, like if the private key of the certificate has been compromised, or if there would be any problem in that certificate. Because of that, the administrator has forcefully revoked that certificate. After the validation of that certificate, client builds chain ciphers back. So till now, we have sent the client hello, client send the client hello, and in the client hello, client send the client random number. When this packet has been received by the server, server has generated the server random number and its own server authentication certificate. It has been sent to the client. So now client has client random number, server random number, and server authentication certificate public key. Now, with the help of the client random number and server random number, the client generate pre-master secret, and that encrypts the pre-master secret with the server authentication certificate public key, and it sends in the client key exchange packet. Once this packet has been sent to the server would be able to decrypt that packet because the server has only the private key of that certificate. Remember one thing, that private key never travel over the wire. So now, if you check that on the server and on the client, what we have. On the server, we have client random number, server random number, and pre-master secret. And on the client, we have client random number, server random number, and pre-master secret. Now, with the help of these three things, client and server will generate master secret. And the master secret would be the same on both the machines because it has been calculated by some mathematical calculations, and it has been calculated by the help of client random number, server random number, and pre-master secret that are same on the client and on the server. Now, after that, server will send the change cipher stack to the client. That means the server is ready for the secured communication over SSL or TLS. So this is a high level overview that how SSL and TLS handshake works. Let's see the same traffic in the network traces. That will give us better information on this. So here are the network traces that I have collected in my lab machine at the time of creating a SSL handshake. My client IP is 192.168.2.54 and the server IP is 192.168.2.52. These traces has been collected on the client end. And if we check the first packet has been sent from the client to the server, and this is for sync. It's a TCPIP sync. The server reverts with the sync ACK. And in the third packet, the client sends the acknowledgement for sync ACK. The TCP/IP handshake has been completed till here. Now the SSL handshake starts. The client sends the client hello. So let us see how does it look like in the client hello. So in the client hello, if you check, this is the information about the TCP/IP, like what is the IP address for the client, what is the IP address for the server. After that, if you will go to secure socket layer, in the secure socket layer, we have the information about the handshake protocol, that is client hello. Client handshake type would be client hello. The TLS version that has been used would be TLS 1.2. And this is the client random number that I was talking about that has been sent at the time of client hello. So this is my client random number. And so this is my client random number. This is my session ID. Session ID is 0 because this is the first session. It has not been renegotiated. So there would be no previous session ID. The client is initiating the handshake because so the session ID is 0. And if you have Pramod, do you have the question on what are the Cipher suites?
Hello.
Pramod,
Hello.
do you have? Hello, can you hear me?
Yes, yes.
So your question would be,
Hello.
what are the Cipher suites, right?
Yes, yes.
So the Cipher suite, if you talk about, it would be the combination of a number of things.
Okay.
If you check this Cipher suite, that would be the TLS EC. Let me take a simple Cipher suite. And moreover, Pramod, if it is possible, can we answer all these questions at the end of the session? Because it would be a lot easier for us in order to answer all the questions at the end of the session. Because like if I will try to answer all the questions as of now, it may break the flow of the presentation.
Yeah, sure.
Thank you. So thanks a lot. Let me continue on this. We have client hello. In the client hello, it has been defined that what is my S channel protocol that has been used? What is the random number that has been created on the client? And the session ID, it is 0 because it's the first handshake. It's not renegotiated, or it's not the resumed session. And after that, we have the list of all the Cipher suites. These are the Cipher suites that are enabled on the client. And how Cipher suites look like would be, if you check this one, RSA would be the asymmetric encryption algorithm. So that would be transport layer security with RSA. with AES 128. AES 128 would be the symmetric algorithm. And after that, GCM, we have SHA-256. SHA-256 would be the hashing algorithm. So it would be the combination of symmetric key, asymmetric key, and the hashing algorithm. That is why it is called Cipher Suite. Okay, apart from that, if you, this is one of the most important thing. This is the name of the server for which I'm sending the client hello. And we have signature algorithms that are supported on the client, like RSA, PKCS 1, SHA-256, SHA-384, SHA-1, SHA-256, SHA-384. So these are the hashing algorithms that are enabled on the client machine. And apart from that, we have session ticket, we have application layer protocol negotiation, and we have extended master secret. Right now the length is 0 because with the client hello it cannot be sent. Master secret cannot be sent. And we have renegotiation if it is renegotiated. So that would be the information with the client hello. So till now, what we have concluded would be with the client hello, it sends the SSL TLS handshake protocol, client random number, session ID, list of cipher suites, server name indication, and hashing algorithm that are supported on the client machine. Once it has been sent to the server, once it has been received by the server, how the server hello looks like. Server builds the server hello on the basis of the client hello that he has got, and the available cipher suites and the available TLS protocol and the hashing algorithm that is available on the server itself. So this is server hello, and the server decided to choose TLS version 1.2 at the record layer. The record layer would be the layer that works over TCPIP, and under the record layer, all the TLS and SSL handshake flows. Under the record layer, TLS SSL handshake works, and change cipher spec works. And if there would be any fatal alert, or if there would be any encrypted alert that we get under record layer. And the version for the TLS that has been accepted by the server, and the server is sending yes, I am okay to talk on TLS 1.2. And this is the server hello packet. And now if you check, there would be a random number. So this random number is from server. This is my server random number. And the session ID has been generated. My session ID has been 32. That has been generated by, sorry, session ID length is 32. This is my session ID. So this is the session ID that has been generated for this session. And the cipher suite that the server and the client will use for further communication, that would be TLS, ECDHE, RSA with AES 256, GCM SHA-384. And apart from that, the server has sent its certificate. So this is my certificate that has been sent to the client. And this is the signed certificate. If you check the details of the certificate, like the subject name and number of extensions. So the relative distinguished name would be ID at common root CA. Root CA would be the name of my IIS server. Please do not confuse with this name. It's the IIS server, not root certificate authority. So this is the subject name. The subject name would be the name to whom the certificate has been issued. So if we check the details of this certificate, this certificate has been issued to rootca.hello.com. And these are the extensions for the certificate, like what is the template that has been used, what is the extended key usage, what is the key usage, and what is the subject key identifier, authority key identifier, key distribution points, authority information access, and subject alternate names. Subject, why the subject alternate names are very important these days right now, because as per the guidelines from Google, and as per the guidelines from any of the secure websites, if you do not have subject alternate name in your server authentication certificate, it will be considered as non-secure. And apart from that, it will, so this is the information that has been sent by the server hello. So to summarize, in the server hello, what we have sent the accepted TLS and SSL version protocol. We have sent the server random number, we have sent the session ID, and we have sent the Cipher Suite on which we will talk. And we have sent server authentication certificate. So till now, what client has? Now the client has client random number, server random number, the certificate of the server authentication certificate. As soon as the server will get, as soon as the client will get all this information, with the help of the, let me go through this. Okay, with the help of the client random number and server random number, the client will generate pre-master secret. And that pre-master secret would be encrypted by the server public key. The server certificate public key has been derived from the certificate that has been sent by the server in the client hello packet. And after that, it will send this information to server. And so till now, I'm just trying to summarize that as simple as possible so that there would be no confusion, because in TLS and SSL handshake, initially it works over asymmetric encryption, and after that it works on symmetric encryption. So now the client has client random number, server random number, and pre-master secret. Client has sent the pre-master secret, which is encrypted by the server certificate public key, which can be decrypted by only server. And once this client key exchange packet has been received by the server, it will be able to decrypt with the help of the private key that is on the server. Now the server also has client random number, server random number, and pre-master secret. So in that way, on the client and on the server, we have the same kind of data through which we can apply some mathematical calculations and we can calculate master secret. With the help of client random number, server random number, and pre-master secret, client calculates master secret. In the same way, the server calculates the master secret. Now client and server both have symmetric key, which is same with the client, same with the server. After that, server will send change cipher spec. Change cipher spec means, yes, I'm ready for secure communication. If you check this packet, change cipher spec, you will not find much information in that. That will say only change cipher spec protocol, change cipher spec, and it's an encrypted handshake message, and that's it. After that, application data starts. Application data means now if you check any packet, all the packets are encrypted. So the symmetric encryption has been started. Now we don't know that what is data is going on. It is because all is encrypted. If we have the private key for the server, yes, we can decrypt this data. But in order to decrypt that data, that would not be the part of the session. But yes, we can do that. If we have the private key of the certificate, we can do that. So again, I am summarizing till now whatever we have checked in the network traces, whatever we have checked in the network traces, and whatever we have seen till now, and how SSL and TLS works. So in the simple words, the TLS handshake protocol involves the following steps. The client hello sends the client hello sent to the server along with the client random number value and supported Cipher suites. Server respond by sending the server hello to the client along with the server random value. The server sends its certificate to the client for authentication and may request a certificate for the client. The server sends the server hello done message. If the server has requested a certificate from the client, that client sends, it's an optional. The client sends the random pre-master secret and encrypts it with the public key from the server certificate, sending the encrypted pre-master secret to the server. And the server retrieves the pre-master secret. The server and client each generate the master secret that is also called session key based on the pre-master secret. The client sends change cipher spec notification to server to indicate that the client will start using the new session keys for hashing and encryption messages. Client also sends client finished message, and the server receives change cipher spec and switches this to record layer security, straight to symmetric encryption. Using the session key, server sends server finished client to the server, and the client and server can now exchange application data over the secured channel they have established. All messages sent from client to server and from server to client are encrypted using session key. So what happens altogether? Initially, we have started client hello. In the client hello, we have sent the client random number. The server generates server hello. It generates the server random number. It sends the server certificate. Client get the server random number and the server certificate. With the help of these three things, it can, with the help of the client random number and server random number, it creates the pre-master secret, and the pre-master secret has been encrypted by the public key of the server, and it has been sent to the server, and server would be able to decrypt it with the private key. This is asymmetric encryption. Once the server and client will have the same symmetric key, and the server can encrypt the data with the same key, and the client would be able to client will be decrypt the data with the same key. That is symmetric encryption. So this is all about how SSL and TLS handshake works. Any questions? And if there would be any questions, feel free to contact us at SSDN Technologies. Our office would be at M50 Old DLF Colony, Sector 14, Gurgaon. And call us anytime on the phone number giving on this screen. So thanks a lot for all the people who has devoted their time in order to attend this session. Thanks a lot for joining the training session, and have a wonderful day.